Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course for version 7, and this afternoon's video tutorial is going to be on Discovery Activity 15, where we're going to take a look at basic redistribution between EIGRP and OSPF. As you can see on the right-hand side here, we have our topology diagram, and so let's go ahead and dive in. The first thing that we're asked to do is to go ahead and right away enable the redistribution of OSPF into EIGRP. So from user exec, I went to privilege exec, and I'm going to move into global config, and we're going to say router EIGRP 100. So first let's take a look. Do show run section EIGRP and see what we have here. So it looks like we have an IPv6 EIGRP configuration as well as the router EIGRP 100 IPv4 configuration with a single network statement. So let's go ahead and issue the redistribute command. And actually, before we do that, since OSPF is going into EIGRP, let's take a quick peek here at router 2. Let's say show IP route, and as you can see, that's currently the routing table for router 2. Let me see if show run section EIGRP. Alright, so there is definitely an EIGRP config in play on router 2, and router 1, if I were to say do show IP route, you can see that we are learning a series. I'll say do show IP route EIGRP to trim it down a little bit. We are learning about a series of routes from 172.16.13.2. So how can I tell who that is? Do show IP EIGRP neighbor. And that is definitely going to be router 2. Okay, so on router 1, let's get back to our redistribution here. So I'm going to say redistribute OSPF 10. Now, remember, I need to put the metric here. Let's go ahead and hit enter, right? So what is the default seed metric for routes, for EIGRP routes? Well, the default seed metric is 0. So when redistributing into EIGRP, just like RIP, the default seed route is going to be 0. And what that means is it's basically infinity. So if I were to now go over to router 2, I'm expecting to see some OSPF, whoops, show IP route, expecting to see some OSPF routes here, or I'm sorry, some EIGRP external routes here, that we've redistributed in from OSPF, and I don't see those. And the reason I don't see those is because they're being redistributed in with a metric of infinity, or 0. So let's change our statement a little bit. Let's add in the metric 1500, and that's going to be for our bandwidth metric. Then we've got the delay. So bandwidth, delay, the reliability, the load, and not MTU, sorry. And there we go. All right. So we've added in all of our K values here that we're going to assign to the routing information that's being redistributed into EIGRP. So now if I come over to router 2 and I say show IP route, take a look at what we see now. We see a series of EIGRP external routes. And you can tell that they're external routes because of the EX. And so if we come up here to the legend, the D stands for dual, the diffusing update algorithm, and the EX stands for EIGRP external. Now, another way to easily tell is the administrative distance for an external EIGRP route is 170. What is it for an internal EIGRP route? Exactly, 90. So the internal routes are more preferred than the external routing information. And that makes logical sense because it's more trustworthy if I'm learning about it from internal sources than if I'm learning about it from external sources. And I missed this guy here. We'll include that guy there. All right. So we now see the information, and the information comes in as external EIGRP routes. All right, so let's go ahead and continue on here, see what we're being asked to do next. So we already did the show IP route here, and we talked about the external administrative distance. So now let's go ahead and configure the redistribution of OSPF into EIGRP v6 on router 1. All right, so I'm going to say IPv6 router EIGRP 200. And again, it's critical that when we go to do the redistribution of any routing protocol into EIGRP that we set those metrics. So we'll say OSPF 20 metric. Now, this is not named mode. And typically, what used to be done is you used to be able to just say 1.1.1.1 and put 5 ones down for your K values. And we could still do that here. I can just simply say, because at the end of the day, the metrics for the external routes really don't make that big of a difference, right? So I can just simply say redistribute OSPF 20 metric 1.1.1.1. And if I come over here to R2 and now say show IPv6 route EIGRP, you can see that we still pick up the routes. Now, obviously the metric is a little higher than the metric we see here, but again, that's a quick and dirty way to redistribute it. If I wanted to make a change to that and actually put in the values that it's showing, I can certainly do that, and this will definitely lower. So 1500, 100, 255, 1, and 1500. Let's come back over and do a comparison here. Show IPv6 route EIGRP, and as you can see there, the metric has dropped a little bit. So the composite metric here with all ones was actually 2.5 billion. So this was actually billion with a B, and if we look down here, it's 1.75 million. So, and this is million with an M. And again, you can get away with the ones. When you're doing named mode, you cannot redistribute and simply say metric 1111 or the 11111. You can't do the 5 ones because you can see we're already at 2.56 billion here. It'll come back, or it actually won't air out. The routes just won't show up because they'll be set to infinity. So make sure that you're aware of that when you're working with named mode. So again, we see the external routing information. We see the administrative distance is still 170. And IPv6 a little different. It just says EX. So no D. It just says EX. And where is the EX at here? There we go. Right there. Right? So EIGRP external routing information. So this is a great way for us to get the OSPF routing information into the EIGRP routing domain. All right. Whoops. So now we're going to go ahead and do the redistribution. Or I'm sorry, they actually wanted us to look at the include connected. Yeah. So if I were to say on router 1, and these are the routes that we're not going to see, do show IPv6 interface brief and exclude down or unassigned. You can see that we see the 2 connected interfaces, Ethernet 00 and 01. However, and if we take a look at that, you can see that it's DB8:0, so it's 10 and 13. So if we come over here, do you see 10 or 13 here? We don't. We see 1, 2, 3, 4, 5, and 192. We do not see the connected interfaces here. And again, it's not necessarily a bad thing. It just depends on whether or not you want to have that information redistributed. So in order to get that added in, let me go ahead and call my command back up here. So where we did the redistribute command, if I do a question mark, you can see that it knows it's IPv6, right? Because we're in the IPv6 config, and so it's going to ask me, or it's going to give me the option to include connected. So now if I were to go back to router 2, we're going to get those connected interfaces. So let's do this. And we should see 10 and 13. And I see 10. And am I looking by 13? And let me see, we're definitely running OSPF on 10 and so why don't we see 13? So we see 10, but we don't see 13. Why is that? And the reason being is we see 10 because it has been redistributed and we're including the connected. We don't see 13. And hold on a second. That actually does not look right to me. And I was about to say, show IP route, that we don't see... Oh, right. We don't see... No, we should see both of these. Show IPv6 route. Hold on. We should see both of those. And am I just looking by... so 13 is directly connected. And that is why we don't see this. That network is directly connected on router 2. Right? So we see 10 because 10 is not directly connected. We see 13 because 13 is directly connected. So it took me a second there. All right. So we'll come back over here to step 5. Now we're basically going to do the same thing in the opposite direction. I shouldn't say the opposite direction. Excuse me. But we included the connected here in step 5, and we confirmed that we do see 10. And there we go. And it explained why. So now, same thing with OSPF. Let's go ahead now and redistribute our EIGRP information, which are going to be those loopbacks 11, 12, 13, 14 over there on the right-hand side, into OSPF. So we're going to redistribute from EIGRP into OSPF. And remember, redistribution is always in the outbound direction. So I'll say router OSPF 10. And then we're simply going to say redistribute EIGRP 100. Now I'm going to do a question mark here. The subnets keyword is very, very important because without it, this keyword right here, it says consider subnets for redistribution into OSPF. And what it should say is classless and so it's going to redistribute everything, right? If I leave that keyword off, what I'm telling OSPF is only distribute classful routing information. So let's say that. And actually, this is fantastic, right? You get this alert, or you get the warning here telling you only classful networks are going to be redistributed. So if we look back at our diagram, let's come down to router 4, and let's see if we see anything that's been redistributed. So you'll notice there are no redistributed routes. And the reason being is that if we look back at the diagram, take a look at the routing information that we have for the loopbacks here. Are any of these classful? Well, and get rid. Don't look at the IPv6 right now. Are any of those classful? No. So 10 dots are class A with a /8 subnet mask. However, we have variable length VLSM in play here, and these are /24s. So that's why nothing shows up for me. So let me come back to R1, and let's run the command properly this time and say redistribute EIGRP 100 subnets. Now if I come over to router 4, say show IP route OSPF, now take a look at the external type 2s that we're picking up. And you'll notice we don't have to supply a bunch of metric values, right? It's not required, I should say. And I apologize, let me move back over here to router 4. It's not required when redistributing into OSPF. And the reason is that OSPF has a default seed metric, right? So this is the default seed metric of 20. So when I redistribute into OSPF, I automatically am assigned a metric of 20. Now, if that isn't the metric that you want, you can certainly change that. So if I were to come back over here, you can see we'll have a lot of options available to us. Redistribute EIGRP 100 subnets, I could say metric. And I can actually assign a metric of, let's just say 99999, right? Well, actually, we won't get too carried away. We'll say 9999. So if I do a question mark, you can see we still have some other options, but I'll hit enter. We'll come back over to router 4, and now let's take a look. Is the seed metric going to be 20? It's not. What is it? It's 9999. And I've also got these in here as E1s, or I'm sorry, E2s, external type 2s. So these are not taking into account the internal costs of the actual network. So from router 4's perspective, he sees the metric as 9999. Now this is irrespective of that cost right there, this cost right here, this cost right here, and then that cost right there. So we've got 4 outgoing interface costs that are not being taken into account because, again, I am a type E2. I do not care about the internal costs. So let's change that and see what that looks like. Let's change it on router 1 here. We're going to change that to metric type 1. So we'll come back over here to router 4 and we'll say do show IP route OSPF. Now, what is the cost value here? What is my metric now? So I assigned a seed metric. The seed metric, which is the default metric that all those redistributed routes will get, was 10073. I'm sorry, it was not 10073, it was 9999. Sorry about that. 9999, and the ultimate metric here is 10,073. So if I've got 10,073 and I subtract 9999, what do we get here? Well, we get 6, 13, 4. Get rid of that. So 9, 9, 16 is going to be 7. So we get 74 as our difference. So we had quite a few hops there, and the difference in the metric is 74. So you can clearly see that the E1 takes into account those additional hops that are here, or no, I shouldn't say hops, but additional outgoing interface costs to get to our final destination. So let's see, we're going to take a look at the show IP OSPF interface, and we're going to walk this path here, and from 4 to 3 to 1 to 2, and we're going to see what the outgoing metric is, and let's see, does it add up to 74? And that's a question mark, not a 7. Does it add up to 74? So let's check that out. So let's get on to router 4 here first, and I'm going to say show IP OSPF interface Ethernet 00. And actually, let me double check that. Sorry, serial 00. So we'll take a look at serial 00. And what is my OSPF cost? Well, it's 64. Right, so 64 there. Let's go to router 3 and look at the Ethernet interface. And we'll say show IP, whoops, not show IP route. Show IP OSPF interface Ethernet 00. And the cost is 10. So that gives me the 74. And again, it's being redistributed from this point right here. So on redistribution, since we're redistributing from this location right here, this cost was 64 for that interface there. That cost was 10. That gives us our additional 64. Or, I'm sorry, our additional 74. So it's not going to take into account that interface hop or that interface hop because, again, where are these interfaces at? Exactly. They're in the EIGRP domain. They are not in the OSPF domain. So from router 4's perspective, it's going to be to his ASBR to where he calculates having to get out of the OSPF domain. So we have an additional 74. And so that's how you can check to see that, yeah, the E1 is doing exactly what it's supposed to do. It's taking into account that additional metric. All right, so let's slide back over here. We took a look at that, and I think we're going to be, yeah, we did metric type 1 subnet, so we did do that. And there you can see that it shows that the additional outgoing interface costs are going to be taken into account. So we're kind of down toward the end here. We're going to take a look at step 11, configure the IPv6 redistribution information. So I'm going to say IPv6 router OSPF 20 and redistribute EIGRP 200, and we're going to say include connected. So for step 12, we're going to confirm this now. Let's roll all the way over here to router 3, show IPv6 route, and there we go. There are my OE2 routes. Now, what's interesting here is that on the OSPF side of the equation, you can see where I am learning an OE2 OSPF route for the 13. But what about the 10? Exactly, directly connected, right? But then I've got my additional information down here, and same thing, external OSPF, its administrative distance does not change like EIGRP's. So EIGRP goes from 90 for internal to 170 for external, right? OSPF, it's 110, irrespective of whether it's internal or external. And then we have that default seed metric of 20. All right, so let's go ahead and clear the screen here. Whoops. I apologize there. Let me slide this back up. All right, so we've already taken a look at the show IPv6 routes. Let's change the metric type so that we can see that the cost is added in. I'm not going to change the metric, but I will change the metric type. And we'll say type 1. Come back over. We'll come all the way to router 4 this time. Show IPv6 route OSPF. And there you go. So you can see that we now have the OE1s, and the cost is definitely not 24. It's 74 more than 24, and we know why that is, right? Because the type 1, or the E1, I should say, not the type 1, the type 5 LSA for an E1. From router 4's perspective, right, we've got a cost of 64 for that outgoing interface, and then a cost of 10. And type 1 says, hey, I do care. I want to know what is the cost here and what is the cost here so that I can make the most informed decision as to how to get out of my network. Now, we've got a single ASBR here, right? So does a type 1 make sense in this scenario? And the answer is no, it really doesn't. So you're probably wondering, well, where would it make sense? And this is really, these Cisco Learning Lab activities are absolutely phenomenal. So I'll just add this in here and say this is router 5. And router 5 is just like router 1. He's got an interface in this area, and we're going to say he's got a serial interface to router 2, and we'll do a small serial interface here to router 4. So what is his role? Is he an ABR? No, he's an ASBR. Right? He's an ASBR. And so now we have 2 autonomous system boundary routers. So, whereas before when we didn't, the E1, that didn't make much sense, did it? Right? It didn't make much sense to, let's take this interface, outgoing interface into account and this one here because I need to know what additional cost I'm incurring. However, now it does make sense because that is 64. And actually, let me do this. I don't want to do a serial interface there. So let's do, yeah, here I'll change. We're going to say that that is not a serial interface. I'm actually going to change colors real quick. We're going to say that that is a gigabit interface, right? And we'll say that we've done the auto cost reference band. Well, actually, it's going to be 1 anyway. So the cost is going to be 1, right? So 1, and then actually, it doesn't take that into account because it's outside the OSPF domain. So in looking at this, does it now make a difference as to whether or not we choose type 1 or type 2? Especially if this wasn't a serial link, and this is just simply an Ethernet connection that's, we'll say it's a gigabit per second, and this is 1 gigabit per second. Do we care now? We certainly do. Because with 2 ASBRs here, now we need to make an informed decision as to which way are we going to go. So is router 4 going to come out through router 5 and up to router 2? Or is router 4 going to go up to router 3 and then to router 1 and then to router 2? And so this is where we really want to know the difference between the costs, right? We want to have an inclusive, all-inclusive accounting for the internal costs I'm going to incur to get that added to the seed metric. So 4 going that way, it's going to be 21, and 4 going this way, we saw already, is 90, what is it? It adds 20, 74, 94. So it's 94. So then we would want the traffic to come out that way. Because if we don't do that, let me clear the screen here. If we didn't do that, and we have router 5 here, and we've got a connection there, connection here, and this is an ASBR, and this is an ASBR, and we don't do the metric type, everything comes in, right? Both directions, they get advertised in with the default metric of 20. So then how does traffic exiting this OSPF domain determine which ASBR it's going to go through? And then that gets down to the forwarding metric, as well as taking into account the router IDs for the ASBRs, right? So this is where an E1 is going to make a difference, and where you would want to do an E1, which is when you've got multiple paths out of that OSPF domain. All right, so let's clear the screen here, and I believe that actually wraps up this activity. So this is a great activity to ease you into redistribution between OSPF and EIGRP, and we did both IPv4 and IPv6. Remembering, the key factors are going to be with EIGRP is that include connected statement, and when you're redistributing into EIGRP, you must put down those composite metric, or the K values, right? You've got to take those K values into account and make sure that you identify them on the command line. All right, well, that wraps up Discovery 15, Basic Redistribution. I will see you all on Monday.